CrewtonRamoneHouseOfMath.com. What's up?
Okay, so do you know what we're gonna do?
No.
Okay.
We haven't done it yet.
This is the point. We haven't done it yet. See, this is the thing. People think that it's all rehearsed and that we spend time and no, half the time you guys have no idea what's coming next.
Yeah.
Okay, most of the time, except like sometimes like okay, we do fractions and then we do a couple of lessons and then we actually put some lessons on film. But this time you have no idea what's going to come. So here's what we're going to do. I want to know. I know you know how to do this. So don't get nervous. Just relax. Factor for me x squared. Oh wait, we already did this. All right, never mind. It's fine. It's fine. X. No blocks. No blocks. No blocks. Okay, just in your head. X squared, 2x, and 1.
X plus 1 and x plus 1.
Okay, so you say x plus 1 squared. Could you say that?
X plus 1 squared.
Yeah, and there it is. We build it for them so they can see real quick. Super easy, right? There's not even hardly any blocks here. Just put together quickly. Alright, easy as pie, right? Okay, so here, all I'm going to do, and I'm going to write this way for these guys at home. X squared plus 2x plus 1, and he factored it, and he got x plus 1 squared, right? I could write x plus 1 times x plus 1, but that takes forever, and we don't want to do that, right? Alright, so let's change it. What if I told you, and it's just before nap time, huh? It's like, seriously, it's like literally 10 minutes to nap time. 10 minutes to nap time! T-minus 10 minutes to nap time. Anyway, so how about if I just change it. I'm going to change what we call it. And I'm going to say I have x squared plus 2xy plus y squared.
Y. Anything. Oh.
Y can be anything. It's the other one. X could even equal y. But 2xy plus y squared. Now factor that. Bum, 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 bum.
X plus y. X plus y squared.
X plus y squared?
X plus y, x plus y.
So wait a minute. Okay, so so you're saying it's x plus y squared. Anything hard about that?
No.
Now all we do is change the names. That's an x squared. Show me the y squared. What'd you do with the y squared?
I don't know.
Show me the y squared. Bring me the y squared. Put it down so we can see it. That's the x squared. Show me the y squared. Okay. There it is. Right? We just changed the name of this. Now this is the y squared. So then show me an xy. Put it over there. There you go. So now this is x this way, and y. And we can even measure. Look, you can see that it's y the short way, and x the long way, and that the whole thing would be an xy. Right? Let's change it again! Oh no! Guess what? This is a squared. This is b squared. This is now what? If this is an a squared and this is a b squared, what would this be?
C squared.
Is that a square?
No.
Suddenly are we talking about triangles? Are we doing anything with Pythagoras?
No.
Alright, so then what would I have?
C.
Is there any c that we could even talk about here?
No. No.
So here's an a squared. Here's a b squared. What would this be? What would this be over here? If this is a b squared, what would that be right there?
B.
B. So what would this be over here? This length.
A.
So what would this be? Get it? No. So what would we call this?
AB squared.
Is it a square?
ABX.
How about just, is there an x?
No.
So what do we call it?
AB.
How about just AB? So here is my... You would try to make this complicated, see? We were just talking about that girl that would try to make things complicated, and that's what you guys do. Try to make it hard. Whenever anything new, it must be math. Is it hard? Never anything hard about it. Alright. So there is my a squared. Here is my b squared. See it? And here is, and this is all for the benefit of you guys at home, is upside down for them, which actually is good. And this is AB, right? So if I have AB and another AB, how many AB do I have?
2AB.
2AB. Alright, so here's what I want. I want you to factor for me. And see, this won't be hard later when they see it. A squared plus 2AB plus B squared. Factor that, please. This was throwing off a high school student. This is from a college student. Did you see an X anywhere in there?
AB.
Just build it. Just build it. Build it. Take the pieces and build it.
AB. It has one of these now. AB.
Do we ever build it like that? Ever? Do the units ever end up over there?
No.
Okay, build it for you. Don't build it for me. Right? So there it is. Anything hard about that?
No.
Same pieces. You guys tried to make it hard though.
AB.
Perfect example. Right? But it's the same thing. It's exactly the same thing. And if you're going to try and we're going to build it for us? Okay, go ahead. See, look, this is great spatial relationships and how to make. All right, great. Thank you very much. The boy builds it for the benefit of the viewers at home. Right? Because then it winds up over there. Okay, so what are the factors though?
AB plus AB plus.
Where's AB? What do I have here? What's this distance?
AB.
Can I call that AB? Is it A times B? Is this distance A times B? Or is this one right here?
AB plus.
This whole thing is an AB. Wait. Oh, I missed the expression. Darn it. Okay, this whole thing is AB. But what's the distance on this one side? I mean, what is it from here to here?
10. No.
We have no tens to work with. We're saying,
plus.
Is it an AB from here to here?
No.
This is an A squared.
Oh yeah, A squared.
So I'm showing it this. This is an A squared. So what's the distance from here to there?
AB.
Where do I get an AB if this is an A squared?
A squared.
The whole thing is A squared. What's one factor of A squared? Think. What's one factor of A squared? How come this is A squared right here? Because why?
Because A plus.
Is it plus?
I don't want plus.
What do we do? Alright, so look at the little brains working. I like it. This is the idea. Alright, let's flip it over for a second and we can talk about 100. So what's the distance from here to here? Is it 100?
10. 10 from here to here.
Okay, you're correct. What's the distance from here to here? 10. Could we say that 100 is a 10 square?
Oh, no.
So now, sure we could.
No,
isn't 100 a 10 square?
I mean, not on this side.
Oh, not on this side. You're right. Okay, you're correct. Okay, but now I'm just using my imagination. I can call this anything I want. I'm calling this an A squared. So what's the distance from here to here?
Half an A squared. No.
Is it half? What's the distance from here to here? In other words, if I square rooted this, what would one side be?
AB.
There's no B here.
A.
So what would the square root of A squared be?
A.
Ah, very good. So because one side of this, they understand the concept of square root. That's pretty good for 6 and 7, I'd say. So one side of this is A, right? Yeah, very good. And the reason why we call it an A squared is because A times A is A squared. Aren't the factors right? And now I can put any number in for A. Now we can talk about the reason why we use X and Y. We usually use... Really? How many of us are here? School has ruined you. Anyway, he raised his hand. Okay, so I recognize the 6-year-old in the room who raised his hand. The court formally recognizes.
A squared plus B squared equals C squared.
That's true. That's a completely different thing, though, isn't it? That's when we're dealing with triangles. Thank you for that. Thank you for that additional information. Now, what I want is dicta. What I want is you to tell me about this. What about this one?
B squared.
That's B squared. So what's one side of that?
B.
All right. So now, if I have a little man that we don't have any little men running around. It's fine. We'd have to stop the video and go run and get one. It's fine. I would just use my finger to pretend he's the little man. In fact, somebody give me a finger besides me. All right. So what do I have if I go along here? What's that distance?
A.
A. What's this distance? Just that right there.
B.
So can I say that this is A times B? Or is this A plus B?
A plus B.
Okay. And this whole thing would be an A times B. Alright. Back up. Move your hand, please. Alright. Now, A plus B
Equals.
squared. Done. Equals.
Wait, sorry.
Equals what?
C.
Is there any C? Have we talked about C? Do you see any C around here?
A plus B?
A plus B squared is what? The same as what?
A.
What do I have here totally? Isn't that what we're talking about?
A squared.
A squared plus what?
A squared plus.
How many ABs?
2 ABs. These 2 are ABs. 2 ABs plus 1.
Plus 1 what?
B.
We're not calling this 1 anymore.
1 B.
1 B? What is this called?
B. B.
What is this called?
B squared. B squared.
It says it right in front of you. So what we said here, and see, this is what I mean, is that you gotta get the concepts home and get them to understand what we're doing. A plus B squared is the same thing as A squared plus 2AB plus 1 plus 1B squared plus B squared. Right? I could write it like this if I really wanted to. I could put 1 A squared and 1 B squared. But why do I need those 1s there? Do I need them? Yeah, get rid of them. Go ahead. You can erase it.
Goodbye.
Goodbye. Out of there.
Don't erase them.
Okay, but we know that A plus B, and this is the thing. From here to here, what's this distance? This distance from here to here is A, the whole thing. It's not the distance. If I want A squared, I'd have to go get one of these long ones.
Yeah.
Right? We'd have to go get into 3, right? If I want an A squared, that's a super long thing.
I know.
Right? I'd have to take this and stretch it out. So what's the distance from here to here? Some massive thinking here. Analysis. It's A. Plus, and from there to there, that distance right there is what?
B squared.
The whole thing is B squared. What's the distance just from here to here, going across there?
B squared.
Is it B squared? This whole thing is B squared.
I mean...
See? What's the distance from there to there?
This boat to this boat? AB. This boat?
Is it AB? This is an AB. Is it multiplied together?
No.
What is it? A. How far is it from here to here? See, the simplest stuff is often the hardest stuff. In other words, what's this distance? From here to here.
This is 1.
How far is this from here to here? If I use this as my measuring stick. How far is that? A. How far is that then?
B. B?
B. So what do I have there? Did I multiply these guys together?
No.
What did I do?
You multiplied them.
I duplied them?
Multiply.
I multiplied them. Did I multiply them?
Yeah.
If I multiply them, I get this. I get this times that.
Oh, yeah.
So is that what I did? What did I do here?
To here?
What did I do?
I factored it.
You did factor it. What do? How do I describe this from here to here? From here all the way across here. How do I describe that? What's that distance?
A plus B.
There you go. A plus B. Right? Really, your little brother and not you. Really? Okay.
I wasn't thinking it would be A plus B.
All it is A plus B. Is there anything hard about that?
No.
Did you guys make that super hard for no reason?
Yeah. No.
Right? Yes, you did. Why couldn't you just tell me that the distance from there to there is A plus B? Alright, because you're trying to be tricky because it's algebra, because you're trying to give us smart answers and stuff like that. Just tell me what you see. Right? That's all it is. Alright, now, so this is A plus B. Now, if I go A plus B the other way, I'm going to have to write this way, and this whole thing.
B plus A.
A plus B, same thing. I'm going A plus B. We're going to read it the same way. A plus B. The whole thing is what? Well, now I have an A times an A, and I get an A squared. See this? And then I get an A times a B and an A times a B.
Equals.
And I get 2AB. And then I get a B times a B, and I get a B squared. Let's put it all together. Because look, if I have an AB, we're talking about A times B. AB, that means A times B, right?
A squared plus...
That's this.
Oh.
See that? That's just an AB. A times B. So let's put some regular numbers in here. Let's say that this was 2, that A was 2. Oh, wait, we didn't finish that other lesson. Hold on a second. We got to do this. A plus B times A plus B. This is what we were doing. That's what this says, right? So that means A times A is A squared. See it? A times a B is an AB. There's that part. Now, B times a A is a BA, but an AB and a BA are the same thing, isn't it? Isn't 3 times 2 the same thing as 2 times 3? People get confused about that. Okay. Because then they get confused about Camden multiplier. But anyway, we'll skip that lesson for another day. Now, I have to multiply the B times B, and what do I get?
B times B squared.
B squared. There you go. Okay, that's all this is saying. Why did you guys make it hard? And what the distance from here to here is how much?
A.
And this much more?
A plus B.
That's it. And A plus B this way. Yeah, there you go. Jinxing. Okay. Very good. Now, let's put some numbers in. What if I told you that A was the same thing as 2 and B was the same thing as 3? Then what? Well, now I'm going to build this. What would my A squared be? If the A is 2.
This.
I understand. What would the A squared be? If the A is 2.
2.
What's 2 squared?
2 squares.
2 squared. What's 2 squared?
4 squared. 4. And then 4. And then 4. And 4 squared.
Alright, just 4. What's hard about that? Now, oh, see, this is the thing. Now, this is a B squared, but it says the B squared is 3. What's 3 squared?
9.
Okay. Uh-oh.
Oh, baby.
Because you see that the B squared in this case, just because, right? Now, oh. There it is. See that? Now, what's an AB? What's A times B? What's 2 times 3?
6.
So I'm going to build it with 3's. See, and there's a 6. But see, it has to be A, there's my 2, and there's my B, there's my 3. See that? So now, when I was talking about AB over here, A times B, right? And don't be fooled, because you know what? The B could be shorter or longer. This is why I picked and made it this way. Because look, when I do it this way in the completely abstract form, you would think that the A is always bigger. The A is not always bigger. Anyway, so here is my AB. This is now my AB. We used to have pieces that stuck together. But anyway, those days are gone.
We have magnets.
Now, can you see that there's another AB? And there's my, there now is my same shape, right? If my A is just now with actual numbers. Now, let's talk about this. What do I have there? What's A plus B? If A is 2 and B is 3.
5. 5?
You don't seem very certain. What's A?
A is this.
What's A?
2.
What's B?
3.
What's A plus B?
2. It's just like 2 plus 3.
Correct. Absolutely. So what is 2 plus 3? Cut it out.
5.
5. There you go. So can you see that really it is 5 here? And it's 5 there? So what's this whole number going to be?
25. 25?
What do you think?
Oh.
Oh, because it's 5 times 5. Doesn't it say a plus b squared? Isn't 5 squared 25? Anything hard about this?
No.
No. But see, we're just doing it in algebra. And if I did it all out, I would say, if I did all the little parts here, I'd say 4 plus 2 times 6 is 12 plus 9.
That would be too complicated.
That wouldn't be too complicated, but that's the way to read this, is 4, another 6 and another 6 is 12, and 9. And if I add that all together, I get 25.
That would take way too long.
That would take way too long. It would be much easier to add these guys together and get 5 and then square it, wouldn't it?
That would be much quicker.
Much quicker. Alright, so here we are just fooling around in algebra. Algebra is just generalized math. Now I can put any numbers in. You guys pick 2 numbers.
Only right now?
Yeah, really, right now. Quick. Just any 2 numbers.
We have to agree on one.
Okay. Agree on a number. What is A going to be? You pick A and you pick B. What's A going to be? Just give me a number. From 1 to 10.
10.
Okay, so A is going to be 10. What's B going to be?
9.
9. Alright, you guys get to figure it out. Yeah, sure. You made it hard for yourself. I don't care. Alright, so
90.
now. 90. What's A plus B?
10 plus 9?
19.
19.
19. Now we've got to square 19.
Oh.
Yeah, we've done it before. You guys do it. Build me a 19 square. And be quick about it.
What's 19? This is number 19.
Grab those. Grab a couple of those. Yeah. Why would you grab that?
9.
Give me a 19 square. A 19 square. Here's that. Get that. Alright, so far you've got 19 one way. We need to be 19 the other way. Get rid of that.
I meant to grab another one.
Yeah. Alright, and then how many's going to go over there? What's going to fit in here?
Another 90. 81.
How's it going to be 90? What's the size of this?
It's 99.
So what's 9 times 9?
81.
Okay.
81.
So what do I have? Add it up. You guys did it. Is that going to fit?
300. Oh my gosh.
So wait a minute. I see the 100. Then what? There's my 100. How much is this?
200 together.
How much is this?
81.
How much is this?
9 times 9 is 8.
How much is this right here?
81.
How much is this right here?
9. Still count.
Okay. And how many of them do I have?
9. Nope.
Count this for me.
9.
Count. You're going to count it by 9s? Why don't you count it the easy way?
By 1s?
By 10s. How many is that?
10, 20, 30, 40, 50, 60, 70, 80, 90.
So really, you didn't know this was a 90. Alright. So here I have 90. How much is that?
190.
So what's 90 and 90?
180.
180. Okay. And then, get that out of there. And then, what else? What's this part right here?
81.
81. Add.
All of these together?
Add all of those together. What do you have? Super easy.
300. 300.
Your big brother's going to save you. What? How many here? Or we can go the other way. How many here?
1.
How many here?
8.
And another 8.
16.
That's 80 and another 80. So what do I actually have there?
160.
160. Alright. What's 100, 100, and another 100?
300.
So what's my answer? 19 squared is the same thing as?
361.
Okay. And there it all is. Laid out in front of you. We didn't get out that one because it would take too much square. But there's my A squared, which was 100. There's my AB's, which is 10 times 9, which is right in front of you, child. 10 times 9 is how much?
90.
Alright. What's this right here?
A 40.
Are you going to count it by 4s?
Tens.
Alright. Then let's do another one. You monkeys. Go ahead, try to make it hard. Pick a number from 1 to 10. You're going to go with 2 this time. We already did that. Try another one. Just pick a number, any number. You don't have to get those out. Just pick a number.
I said 3.
We already did 2 and 3. Do a number.
A 1.
Okay, we could do 1. We didn't do 1. A is 1. What's B?
B is 2.
Okay, we can't pick 2 or 3.
4.
Alright, fine. Now it's just going to be the same thing, isn't it?
5. Yeah.
What's 5 squared?
5 squared is 25. 25.
Alright. Pick another 2 numbers.
5. I called it.
You called it. A is 5.
B is 6.
Alright,
Oh
fine.
my god, 5 and 6.
Should be super easy. What's
15.
A plus B?
15.
What's A plus B?
Oh, not A plus...
Don't say anything. What's A plus B?
Same thing. It's the same thing as 6 plus 5.
Which is?
Equals 14. 14.
6 plus 5 equals 14?
I did it in my pyramid.
You never added a 6 and a 5 and got a 14.
Oh, yeah.
Stop.
So, was it 14? Oh, no. Oh, yeah, 11.
How much is it?
11.
11.
I meant to say primary 11.
Okay. So, what's 11 times 11?
121.
We're back to where we were, and we're going to stop. 100. Very good, little boy. Redeemed yourself there in the very end. 100.
He got saved.
21. Yes, he got saved. Alright. But see, this is all it is. And it's not too bad because it's nap time. And the boy is 6 and he's tired. But the fact that you would try and say that 5 and 6 would be more than...
I meant
come on.
to say my 11 to get...
Alright, you meant to say 11, I know. But I mean, 14? Really? Yes. Bury your head. Alright. Now, and there it is, 121. Fooling around with A plus B squared, so that when they see this, it's no big deal to factor it. If they see this, if we just change it, and now I say it's x squared plus 2xy plus a y squared, is it any different?
No.
It's the same thing, we just changed the variables, and now I have an x plus y squared. See that? And then what if I did, and then the last one, of course, if we just do regular x plus 1 squared, what would I get?
X plus
1 squared, tell me.
X squared, 2x, and 1.
There you go. Alright?
Equals?
Fooling around with the most basic, simple algebra. Alright, just fooling around with it. You know how far ahead of your compatriots you are? You have no idea.
What are compatriots?
Yeah, your classmates. People that are your same age, 6 and 7. Right? I give you a hard time because you're I give you a hard time